Alrighty, Unit 4, Day 3, Solving Inequalities by Multiplying and Dividing. So, much like yesterday, we're basically going to be solving these inequalities much like we solved our, much like we solved our equations by doing the opposite operation. Now, the only thing that we have to really remember whenever we're doing the multiplying and dividing is the second piece of the instructions right here. It says to remember to switch the inequality sign when dividing or multiplying by a negative. Okay? That's extremely important. Alright, so on number 1, we've got 2x greater than 6. In order to solve this, we have to divide each side of this by 2. And it's going to leave me with x greater than 3. And we already know how to graph these. So 3, open dot, and x needs to be bigger. So we go to the right. Alright, on number 2, multiply both sides by 5. That's going to be negative 5 is greater than a. So negative 5 with an open dot, and a needs to be smaller. So it's going to be everything to the left. Alright. Number 3. On number 3, we are going to divide each side of that by negative 3. And that's going to be negative 4. We're going to have an x left over on the other side. Now we need to make sure, since we divided by a negative, we have to flip our sign. Like that. Giving us a negative 4 right there with an open dot, and x needs to be bigger than the negative 4, so it's going to be everything to the right. Alright, now y'all are probably wondering what's going on between 2 and 3. Okay, on 3 we divided by a negative number. On number 2, we multiplied a negative number by a positive. Okay? If we multiply or divide by a negative, then we have to change the sign. If we multiply by a positive, it's okay. Alright? On number 4, we have to divide both sides of this by negative 7. And that's going to leave us with 0 less than or equal to x. So we put a 0 in the middle. And there we go, a dark dot above the 0, and x needs to be bigger. So we're going to go to the right. Alright. Now number 5. Okay, let's see. We can solve number 5 very simply by multiplying both sides by 4/3, multiplying by the reciprocal. Alright, and multiply this by 4/3. Alright, that's going to give me b being greater than or equal to 3 times 4 is 12, 1 times 3 is 3. 12 divided by 3 is 4. So we're going to put a 4 in the middle with a dark dot above it, and b needs to be bigger than that. So we're going to go to the right. And there it is. Alright, number 6. We're going to multiply both sides by negative 2 That's going to get rid of the negative in front of the k and get rid of this 2 on the bottom. So multiply that by negative 2. Since I'm multiplying by a negative, I need to switch my sign. That's going to be k less than negative 3. So I put my negative 3 in the middle with an open dot. K is smaller, so we're going to go to the left. Alright. And moving right along. Number 7. We're going to divide each side of this by 15. Divide that by 15. Divide that by 15. That's going to be negative 2 greater than or equal to y. So we put our negative 2 in the middle. We're going to put our dark dot above it. And we can, let's see, that's going to be y needs to be smaller. So that's going to be everything to the left. Alright. And then the next thing, number 8. We're going to multiply both sides by 3 halves. And it's going to leave me with b less than negative 3 over 6, which reduces to b less than negative 1/2. Go ahead and put that on the graph here with an open dot, and b needs to be everything smaller than that. Okay, so some of y'all are probably wondering, is there any way to check these? Well, yes, there is. There's always a way to check your work. Okay, on this, something that you could do for number 8 is a number that is, well, smaller than negative 1/2 would be negative 1, right? Take negative 1 and plug it in. Is negative 2/3 less than negative 1/3? Yes, it is. So I know that this is, at least, if it's not exactly correct, it's very close. Okay? On number 7, what we can do is we can take this negative 2 and plug it in for y. Okay? And that's going to give us negative 30 equals negative 30. And we know that already. But we need to see if the stuff that's considered a part of our answer is also true. So stuff that would be smaller than negative 3 or negative 2 would be like negative 3. Negative 3 times 15 is negative 45, which is less than negative 30. So that has been checked. And there's always a good way to check these answers. So go through and try to, find them. Okay? Make sure that you're right. Next thing, numbers 9 and 10. Moving on to our word problems. Alright, it says the opposite of 1/3. Okay, so when it says the opposite of 1/3, it means negative 1/3 of a number is greater than 9. So greater than is going to be this one. 9. Okay, so we're going to multiply both sides by negative 3 over 1. Multiply by negative 3 over 1. So that's going to leave me with n being greater than negative 27. So I put a negative 27 here. And that's going to be an open dot above the 27. And n is going to be everything bigger than negative 27. So that way. Alright. Now, whenever I go to check this, I can plug in, let's look at negative 28. See if that works. Okay. Negative 28, or no, negative 26 would be considered a part of the answer set. There we go. That's what I was trying to get at. negative 26. Okay, negative 26. I plug that in. Let's see, negative 26 divided by 3, and don't really like that. That's going to wind up being something that's not so great. What about negative 24? That'd be better. Negative 24 divided by 3 is negative 8. Or rather, positive 8. It winds up being positive 8. Is that greater than 9? No, it's not. So, by checking my answer, I was able to find out that this is going in the wrong direction. Okay, and I can go back and I can check to see what I did. Okay, I multiplied by negative 3 on both sides, and oh, there it is. I didn't change the sign. Okay? Okay, so n needs to be smaller than negative 27, and if I go and do that, it makes it work. Okay, if I go negative 30, let's look at negative 30. So if I plug in a negative 30 for n, that would be positive 10, and positive 10 is in fact bigger than 9. So that would work, and that is how we check our answers, and we make sure that they're right. The product of a number and 3 is at most 30. The product of a number n and 3 is at most. So that means that it's going to be the less than or equal to 30. Alright? So we divide each side by 3. That's going to be n less than or equal to 10. So we've got a 10 there. We're going to have a closed dot. And n needs to be smaller. So we're going to go to the left. And there it is. Okay? And if we plug in a 10 for that, that's going to be 3 times 10, which is 30. Okay, if we plugged in a 9, that'd be 27, which is smaller than 30, which is good. Alright, and we can just kind of check it as we go along. Alright, back sheet. Let's go. Almost done. Twice a number is at least 5. Okay, so twice a number, so 2 times a number is at least 5. Okay, so that means that 2n can be bigger, okay, or equal to 5. So we divide each side by 2, and that's n needs to be greater than or equal to 5 halves. So we do 5 halves with a closed dot above it, and n needs to be bigger than that. So we're going to go to the right. Alright? The opposite of the quotient of a number and 4, so the opposite of the quotient of a number and 4 is fewer than 8. So we need to multiply both sides by negative 4 to kick this party off. And that's going to leave me with n greater than, notice how I flipped my sign because I multiplied by a negative, greater than negative 32. So it's negative 32. And then let's see, we need an open dot above the 32, and n needs to be bigger than that. So we're going to go to the right. And there it is. Number 13, the solutions of which inequality are not represented by the following graph. Alright, so we need to go through and solve each of these inequalities and see which one of these does not produce this graph. So let's see, on A, it's going to be x needs to be greater than or equal to negative 4. because I multiplied both sides by 2, right? And I get that. Okay, divide each side by -5 on b, and that's going to be x. Since we're dividing by a negative, that's going to be less than or equal to -4. Okay, that means that we'd have to shade it to the left. So B is the correct answer. But let's go ahead and check our other answers just in case. We divide each side by 3. That's going to be x greater than or equal to -4. Divide each side by -7. And it's x less than, or nope, greater than or equal. Whoopsie. Greater than or equal to -4. Let's see if I can write correctly. Okay, -4. There we go. Okay, so yes, indeed, B is the correct answer. Alright, and now it's time for the word problems. Okay, it says for problems 14 through 17, write and solve an inequality for each problem. Define the variable. Okay, we've been doing that for the last couple of days now. Okay, defining your variables is incredibly important. It lets, especially when we start talking about physics and other stuff like ways down the road in your math career, it's going to be important. Okay, so Joe goes to the store with $16 to buy salad. Bags of pre-washed salad are on sale for $2 each. What are the possible numbers of bags Joe can buy? Okay, so I'm going to say B equals the number of bags of salad. S-A-L-A-D. Okay, so they're $2 each, and we're going to do 2 times the number of bags, and we're on a $16 budget, so we need to spend less than $16, and we could spend $16 if we really felt like it. So we divide each side by 2, and that's going to leave us with B being less than or equal to 8. And there's that. Number 15. By selling old CDs, Sarah has a store credit of $162. A new CD costs $18. What are the possible numbers of new CDs Sarah can buy? Alright, so let's see. By selling old CDs, Sarah has store credit of $160. A new CD costs $18. Okay, so here's what we're going to do. We're going to do 18. Oh, we got to define our variable first. My fault. So we're going to go C is the number of new CDs. Okay? And I know CDs are kind of the ancient technology, but hey, they still work. So we've got 162 is our store credit that we have. Alright, now we need that number to be bigger than 18 times C. Now we could go all the way up to 162. Okay, we could get $162 worth of CDs if it's possible. So we're going to divide each side of this by 18. Alright, and 162 divided by 18 is 162 divided by 18 is 9, which needs to be greater than or equal to C. Okay? Now, some of you are like, wait, 9 needs to be greater than or equal to C? That doesn't make a lot of sense. But if you look at it on the other end of things, C needs to be less than or equal to 9. Okay? These two are the same statement. Okay? Notice the small end is going towards the C. Small end is still going towards the C. So, still works. Alright? Okay. Last two questions, okay? At an online bookstore, Kendra bought 4 copies of the same book for the members of her book club. She got free shipping because her total was at least $50. What was the minimum price of each book? Okay, so we're going to go with, let's go with P equals price of books. Okay, so 4 times the cost of the books needs to be, at the very least, needs to be 50. So that means that needs to be bigger than 50 or equal to. We divide each side by 4. Okay, and P is going to be greater than or equal to $12.50. Okay, so P has to be greater than or equal to $12.50. Alright, so a teacher buys a 130-ounce bottle of juice and serves it in 5-ounce cups. What are the possible numbers of cups she can fill? Define the variable. So let's go with C is the number of cups. Okay, number of 5-ounce cups. Okay, so 130 needs to be bigger than or equal to 5 times the number of cups. We divide each side by 5, and that's going to be 26. Needs to be greater than or equal to C. Okay? Which that basically just says that 26 is the largest number of 5-ounce cups that the teacher can pour out of a 130-ounce bottle. Alright, thanks for watching.